question says a photon is scattered when hitting an electron. The wavelength of the incident and the scattered photons are represented by lambda I and lambda f respectively. Which of the following is an expression for maximum energy that can be given up to the electron, resulting in lambda f max? Now we are talking about the maximum energy, and as you know, we are going to take, we will be taking, one second. We will be taking this formula from here and we'll put it up there. So what is this formula? E I minus E F will be equal to, that is the kinetic energy on the electron, right? So that will be equal to Hc bracket 1 over lambda I minus 1 over lambda F. Let's take an LCM. This becomes Hc lambda F minus lambda I over lambda I into lambda F. And since we want this at the maximum value, at the maximum lambda, so what is the lambda F minus lambda I for maximum, which we can take from here? It is lambda, delta lambda max is 2H ME in 2H upon MEC. 2H over MEC, correct? This is your delta lambda max, correct? When this is max. Now we'll plug this value in here, all right? So we get Hc 2H over mass of electron into speed of light into lambda I in lambda F max. From here, C and C get cancelled. H becomes 2H square over mass of electron lambda I, lambda I, lambda F max. That is your change in the, this is the kinetic energy max, right? So this gives us, this is the answer. Let's figure out, this matches the B answer. This is your correct answer.